Okay, so we're gonna solve number 1. I'm gonna read it first. Stephanie serves a volleyball from a height of 0.8 meters and gives it an initial velocity of 7.6 meters per second straight up. The question is asking how high will it go and how long will it take the ball to reach its maximum height. So since this is our first problem, I'm just gonna actually explain this with words, but when we solve a physics problem, I like to think of it as in like 4 steps mainly. So step 1, I think you guys can guess what it is, but it would be to draw a picture. I can't emphasize enough how much you need to draw pictures in physics. So we're gonna do that. So we have Stephanie and a volleyball. I'm gonna call this our ground, just, you know. And we have a volleyball, and it is served from a height of 0.8 meters. I'm gonna write that down here. And it's given an initial velocity of 7.6 meters. So it's going straight up. I'll write that arrow. And we're gonna have, I'm gonna call this V, let's call it V0, initial V0, you know, same thing. And, well, how is this ball gonna move in this story? It's pretty obvious how it's gonna move. It's gonna go up, like this, and then it's gonna come down, right? So, one thing about the ball when it's at the very, very top, there's some things we know about the ball when it's at the very top. For instance, we know that this is gonna be the maximum height. That's what I'm gonna call this. So this is like as high as it's gonna go. I'm gonna call that capital H. What else do we know? We know something about the velocity. I'm gonna call this V1. I don't know, V1. Okay, it can be V1, V final. Doesn't really matter. We know something about that. I'm not sure how well Professor Purcell's explained this in class, but when something is at its very maximum height, right before it starts falling, the velocity is gonna be 0. Why is it gonna be 0? Because there's a constant downward acceleration of gravity. So we have acceleration going downward. You should always write that down too. But, and then one more thing. We wanna set our direction of which way is positive. I'm just gonna call up the positive, okay? So if up is positive, this velocity is going to be positive because the arrow is going this way. Acceleration is going to be negative because acceleration is going downward. Okay, so, you know, I think that's a pretty good picture to start off with. We're going to probably be adding more as we go, but just for now, this is good. Now, step 2. I want to just organize my knowns and unknowns. So a little trick you can do in your picture too is you can circle the variables that you don't know. So for instance, we don't know what the maximum height is. What else do we not know? I can just add this right now, but we don't know how long this whole, oops, sorry, I don't mean it, okay. We don't know how long it takes for the ball to go from right here to here. I'm also gonna call this position A for, you know, clarity's sake. And then this is gonna be position B. We do not know how long it takes for the ball to go from A to B. I don't know the time. What else do I not know? I don't know the maximum height it goes, but I also don't know this distance from where Stephanie, right? Stephanie has an initial height of 0.8 meters. I also don't know what this segment, I don't know how long this is. So I'm just gonna also call this x, and I'm gonna circle that. Okay, so now knowns. We know that the initial velocity, v0, is positive 7.6 meters per second. What else do we know? We know that v1, the final velocity when it's at the very, very top, there's a moment that the velocity will always be 0. So we know it's 0. And we also know the acceleration, negative 9.8 meters per second squared. Now our unknowns. We don't know a lot, and that kind of sucks, but we don't know h, we don't know t, we don't know x. Is that about it? Yeah? Okay. So, we got some stuff to do. Now, step 3 is equations. I always like to have my equations in front of me. I know you guys have the paper, you can look at that, but I do find that writing them helps you understand them a little bit. So I'm just gonna quickly write them right here. And also, since it's the first time solving this with you guys, I wanna explain them just a little bit. I don't know how well I can do that, but in your equations worksheet, do I have it? Sorry. Okay, here we go. So in this worksheet, I think it's not very clear what exactly all these letters mean, right? So let's take this first one. V equals V0 plus AT. I'm gonna call that V final equals V0 plus AT. What is this saying? So this is just saying that the final velocity equals the initial velocity plus the acceleration and how much time passed. That's it, okay? So the next one, x equals v0 t plus half of at squared. That's just, another equation. We want to know the displacement. Another thing about this x, it usually, we have like coordinate systems of x and y, and I think it can get confusing of this x and this x. They do not mean the same thing. This x just means how much displacement there was. How much did we travel? So in our case, with this volleyball, our x, the distance that we traveled, it has nothing to do with the horizontal component. It has to do with the vertical. That's why I set this height to x, because that's the distance that we moved. That's what we're interested in, okay? So I think that's also okay. And the other one would be V final. I'm gonna be using this one, but I kind of write it in a different way. I move this V0 squared to the other side. It doesn't matter, it's just how I write it. So do what you like. V final squared minus V0 squared equals 2ax. This is another really useful equation that we're going to use a lot, so keep that in mind. And now I think we're ready to try and solve the problem. So step 4, solve. And this problem, we have 2 parts that we need to solve. We have A, which is asking for how high will it go. What does that mean? We want to know capital H. So we want H, but if we want H, we also need to know what X is, right? We know it starts at 0.8, but we also need to know how high it goes. So H and X, that's what we want to know. looking at, so I'm gonna look for x. Does that make sense? I hope that makes sense. I'm gonna look for x. I'm gonna look at my equations that I have. Which equation do you think I can use? I'm gonna number these. I have equation 1, 2, and 3. When I look at an equation, say I want to look for x, if I have more than 2 unknown variables in that equation, I cannot use that because there's going to be 2 unknowns. You can't solve for a single variable. So I'm going to look at the equations that have x in it. Okay, number 2 has x in it. Do we know all the other variables? Do we know v initial? Yeah, we do. It's 7.6. Do we know the time that it takes from the ball to go from position A to position B? No, we don't know the time. So we cannot use equation number 2 right now. Let me look at number 3. Do we know the final velocity? Yes, we do know the final velocity. It's going to be 0 at the very top. Do we know the initial velocity? Yes, we also know that. Do we know the acceleration? Yes, we do. So I think we can solve for x using equation number 3. So I'll write that down. Use number 3. And the rest is going to be plugging in information in algebra. So I'll quickly do that. We have v final squared minus v0 squared equals 2ax. We want to solve for x. So what am I going to do? I'm going to divide both sides by 2a, v final squared minus v0 squared all over 2a equals x. I'm going to flip it, just the right and the left side, because I like how that looks. V final squared minus v0 squared 2a. Yep. What is v final? V final is 0 squared minus v initial. That's 7.6. 7.6 squared. Don't forget that. 2. Acceleration. It's not 9.8, it's negative 9.8. Do not forget that. And now I'm just going to plug that into my calculator, and I believe the answer should be something like 2.94 meters. Okay, so we have x now. Is that our answer? No, that is not our answer. That is just the displacement from right here, position A to B. The question is asking, what is the actual height that it reaches, h? So I think this is pretty straightforward. H just means this initial height, 0.8, plus the amount that it traveled, 2.94, which should give us something like 3.74 meters. So that is part A. Sorry, it's a little dark. Okay, now part B. How long will it take the ball to reach its maximum height? How long? That's asking for time. Let's look at our equations. Let's look at number 1. V final, we know that. V0, we know that. Acceleration, we know that. And we have time. I'm going to use number 1. But you can also use other equations if you'd like to. We know what x is because we just solved for that. We know v initial, and we have time here. We can use equation number 2 if you'd like to, but you know, you got like a square in there. It's going to be like a whole thing. So try and find the best equation to use, a simple one, because it's there. So I'll use equation number 1. V final equals V0 plus AT. I'm solving for T. I'm going to subtract V0 from both sides. V final minus V0 equals AT. Now I'm going to divide both sides by A. So we got V final over V0 over A equals T. I'm going to flip it again because I like it to look like T equals. So V final minus V0 all over A. Now we put in our numbers. V final is 0. What is V initial? 7.6. And what is our acceleration? Again, negative 9.8. Put that in your calculator, and your time should be something like 0.775 seconds. That should be. I don't have the answer key to this, so I pray that I'm solving this correctly, and I'm so sorry if it's not, but yeah. Okay, that is number 1. Hopefully that made sense.